we go. All right. So today what I want to talk about is I want to talk about some algebraic expressions, properties, that kind of a thing. Quick review, and then you can get going on some of the stuff that we have going on today. Okay? So there are a lot of properties out there in math. Okay? Now, of these properties, I don't necessarily expect you to be memorizing their names per se, but I do expect you to know what these properties do. Okay? So, for instance, the commutative property is means that you can multiply or divide add or multiply in any order. Okay? The associative property goes with that and says that you can do multiple addings, multiple multiplications in any order. The identity says that you can do, when you add the additive identity, nothing changes. So in this case, when you add 0, when you subtract the additive identity, nothing happens. Multiply or divide by the multiplicative identity, nothing happens. Okay? Inverses get you back to the identity. Okay? When you multiply by the inverse, or when you add the inverse, it gets you back to the identity. Okay? And then the distributive property says that you take this, and if you still need to draw in the arrows like me, because that's what I do still, you can still draw in those arrows and all that fun stuff. Okay? Know what they do, not necessarily need to know what property is what. In math, we have two different things called an expression and an equation. Okay? Expressions are numbers and variables and have operations. 3x plus 7 is an expression. Okay? The only thing that we can do with expressions is simplify them. Okay? An equation has an equal sign. That's the kicker. And that's what we solve. In this expression, 3x plus 7, I can't solve that. I don't know what x is, okay? Because there's no equal sign. But if I say 3x plus 7 equals -2, then I can solve that. I can subtract 7 from both sides, then divide by 3 from both sides, and I can get a value of what x is because there is an equal sign there. Okay. Powers. The kicker with the power is that the exponent little side note, this is the first time that I've written on a board, smart board, since March, and it's glorious. Okay? Okay? The exponent only controls what is right in front of it. Okay? So this exponent of 4 is only controlling what's right in front of it, which is the 3. So then this is 3 times 3 times 3 times 3, which is then 81. Okay? Here, on this one, this 4 is only controlling what's in front of it, so that's just 3. So there's a negative sign, and then it's 3 times 3 times 3 times 3. So then that is negative 81. Because that negative sign right here, that is not in front of the, or not being controlled by the exponent. Sorry, I was looking for my eraser. Oh, there it is. It's a big one. Okay. I had to, again, haven't used this in a while. Got to figure out where everything is again. Okay. Now, when there's parentheses, then this exponent of 4 is controlling that whole parentheses. So this one is negative 3 times negative 3 times negative 3. So then that one becomes 81. Okay. Here again, that 3, the exponent of 3 is only controlling the 3, so that negative sign comes along, and then it's 3 times 3 times 3, which is 27, negative 27, because the negative sign is out in front. Controlling the whole thing because of the parentheses. So then this is negative 3 times negative 3 times negative 3, which is negative 27. Okay? So what that exponent is controlling is very, very important. Okay? So we got some of those to deal with, and we'll deal with more of these as we go along. Okay? Evaluating expressions, common term here, evaluating expressions, not solving. Evaluating is different than solving. So evaluating says that you are going to take this value, what x is equal to, and you are going to replace it anywhere in the expression that it is. So this is 4 times 3 squared minus 2 times 3 plus 3. Okay? So 3 squared is 9. 2 times 3 is 6. 4 times 9 is 36. 36 minus 6 is 30. Plus 3 is 33. Okay. Same if they're negative. We're going to take, we need to evaluate when m equals negative 2. So we're going to put it in all locations wherever there's an m. Okay? So then this is going to be 8 times negative 2 plus 2 times negative 2, then minus 9, then cubed, then minus 2 times negative 2. Now, if you need to write all this out, that's great. Okay? I never, ever complain about too much work being shown. But the next slide is going to talk to us all about PEMDAS. Please excuse my dear Aunt Sally. So we'd always start on the biggest ones. Okay? So 2 times negative 2, that's going to be negative 4. Negative 4 minus 9, that's going to be negative 13. Negative 13 cubed is going to be a big number. Okay? Because it's 169 times 3 is 2,197. but that's negative because it was negative 13 times negative 13 times negative 13. 8 times negative 2 is negative 16. Negative 2 times negative 2 becomes positive 4, or 2 times negative 2 is negative 4. Subtracting a negative is like adding. So all told, we get negative 16 minus 2,197 plus 4 gets me negative 2,209. Yeah. Sometimes, hate to break it to you, math, not nice. Okay? Nothing you can't do, but sometimes, numbers get big. Happens. I'm over it. Okay? PEMDAS. Please excuse my dear Aunt Sally. So what we're saying here is, first, you need to do parentheses. Then, that might even be A. We'll kind of make it look funny. Then, you need to do exponents. Then, you need to do multiplying and dividing. Those two we do at the same time, left to right. Then, adding and subtracting. Again, left to right at the same time. Okay? So, if we had some expressions like this that we were going to be simplifying or evaluating the expressions, okay? So the first thing that we would do would be parentheses. Well, here's a set of parentheses. 4 minus 2 is 2. So this in my brain is 3 minus 2 times 5. Next one, exponents. No exponents to do. Next one, multiplication or division. Well, that one's right here. We can do this multiplication right here. That's going to be 10. 3 minus 10. No more to do. Add, subtract is left. So we're left off with negative 7 as the evaluation of this one. Okay. Just remember too that you can pause the video at any point in time. Okay? So, parentheses are going to be first. Exponent within the parentheses, 2 to the second power is 4. So then this is 4 plus 3. So 4 plus 3 then is 7. So this really is 21 divided by 7 minus 10. Multiplication division is next. So this one is 3 minus 10. 3 minus 10 is negative 7. Okay. Two very much different looking expressions can be evaluated to be the exact same thing. Third one, 3 plus 4 divided by 2 times 6. So I'm going to be working here the no parentheses, no exponents. So I'm going to work the multiplication and division. I'm actually going to work it left to right. So I'm not going to take this all at once. I'm going to take these two first. 4 divided by 2 is 2. Then times 6, that is 12. So this becomes 3 plus 12, which is just 15. Yeah. Any questions on that? Feel free to jump in into the office hours, send me an email, all that fun stuff. Okay. Last topic for today, combining like terms. Okay. The coefficients get added or subtracted, but everything else stays the same. So we have to look for terms that are exactly alike. So I'm looking for any other cubic terms. Well, the other cubic term is there. Okay? So 9x cubed minus 5x cubed means that I only have 4x cubes. If I've got 9 pencils and you take 5 away, I only got 4 pencils left. My next one then, x squared terms. There's another x squared terms. 2x squared plus 11x squared gives me 13x squared. If I have 2 markers and you give me 11 more markers, now I've got 13 markers. This one doesn't have any other like terms with it, so it just comes along for the ride. And that is my answer, because all of these orange terms are all different. They're not the same. Okay, so I can't combine them any further because they're all the same. Okay. Numerous times you'll have problems like this where you've got to do some distributing first. So this is really 2x squared minus 2y minus 9x squared minus 18y. Then go through and combine your like terms. You've got an x squared term and an x squared term. Those two combine to be negative 7x squared. You've got a y term and a y term. Those two combine to be negative 20y. And that, ladies and gentlemen, is your final answer, because you can't go any further with it. Okay. That was it. That's it. That's the quick, shortened video for today. You can start working on the homework assignment that is posted on It's Learning Too. You can, if you can get done with it, great. If not, we'll go over more of the stuff for tomorrow. Have a great day.